In this video, we will be looking at section 2.1, which covers linear functions. So let's start off with some definitions. A linear function is a function where the rate of change is constant. The graph of linear functions is a line. What's kind of cool about the word linear in and of itself is the word line is created out of the first four letters. So that helps us remember. Linear functions, when we're writing them as an equation, they can be written in the form f of x equals mx plus b. Hopefully this is a form you're fairly familiar with. When we're in this form, our m value is our slope. We're going to talk about that in just a minute. And b is going to help us with our y-intercept. So this idea of a slope, it is the rate of change of a linear function. We say that linear functions are increasing if the slope is positive, and it is decreasing if the slope is negative. When it comes to finding the slope, we use the letter m to represent slope. We can think of slope as rise over run, or as delta y over delta x, meaning the change in y over the change in x. And the way we actually compute this is if we are given 2 points, x1, y1, and x2, y2, we can take the difference between the y's over the difference in the x's, as long as we put corresponding x and y first and corresponding x and y second. Since we're dealing with functions, we could also think of this as f of x2 minus f of x1 over x2 minus x1, because this function notation is just having us evaluate the function at the x value, which is typically what a y value is anyway. We're going to create some linear functions. Nathan currently has $35 in his piggy bank. Go Nathan! If he is able to add $5 each week to his piggy bank, write a function m of w to represent the amount of money m Nathan has in dollars after w weeks. So we're trying to write a linear function of the form, m of w. So w is going to be our input variable, and we're going to get out an m value. We know that m represents the amount of money, and w is the number of weeks. Well, we were told that Nathan is already starting with $35 in his piggy bank. He is adding $5 to this amount every week. So that 5 is going to be our slope. It's our rate of change. And our slope value is what gets multiplied by our input. So for example, if we are going 1 week in the future, then we let w equal 1. 1 times 5 is 5. Adding to his original $35, Nathan's going to have $40. Another week later, we're going to add another 5, and so on. For the second part of this example, it says Nathan's parents, on the other hand, have $150 set aside as their Nathan's allowance fund. If they are taking out $5 each week to give to Nathan, write a function r of t to represent the remaining amount of money r the parents have in the fund after t weeks. So this time we're writing a function r of t, and that's the amount of money remaining. The parents started off with $150, so that's their initial value. They are taking out $5 each week, so they are losing or subtracting $5 each week. This time our input variable is t for the number of weeks. So we start with $150 and we subtract $5 each week. So we're getting the function r of t equals 150 minus 5t. We're going to continue working with our linear functions. It says if f of x is a linear function such that f of 3 equals 5 and f of negative 2 equals 7, find an equation for f of x. So we know this is a linear function. and we were given 2 points on this line. F of 3 equals 5 means that when x equals 3, y equals 5. So that's 1 point on our graph. We were also told that f of negative 2 equals 7. So we get negative 2 comma 7 as our second point. We need to find the slope of this line, and we know that our slope m is given by y2 minus y1 over x2 minus x1. I'll use 3, 5 as my first point and negative 2, 7 as my second point. So my y for the second point is 7 minus my y from the first point is 5 over negative 2 minus 3. 7 minus 5 is 2. Negative 2 minus 3 is negative 5. So our slope is a negative 2/5. It doesn't matter if you write the negative in the denominator or the numerator or out front of the whole fraction. As long as you have just one negative sign, it means the same thing. From here, there are 2 ways we can go about writing our linear equation. Some people prefer to use y equals mx plus b. But realistically, because we're writing a function, let's use function notation. So f of x. The other form we have is using point slope form, which is y minus y1 equals m times x minus x1. Either way, we're going to get to the same place. So let me show you both ways through it, and then you can just pick which way you prefer. So here we're looking at f of x equals mx plus b. I need to pick a point on this line, and I need to use my slope. So I'm going to work with 3 comma 5. That is an x value and a y value. And I know that my slope is negative 2/5. So f of x, or my y value, is 5. That's equal to my m value, negative 2/5, times my x value, 3, plus b. And now I need to solve for b. So 5 is equal to negative 2/5 times 3 is a negative 6/5 plus b. If I add 6/5 over, I get that b is equal to 31/5. You can use a calculator if you need to. Once we know what b is, we need to plug it back into our function. And our function is f of x is equal to m, which was negative 2/5, x, plus our b value is 31/5. So if you like using y equals mx plus b, or since it's a function, f of x equals mx plus b, that's perfectly fine. This is our point slope form. Or sorry, slope intercept form. Slope intercept form. This one is our point slope form. This is used really well if we have a point and a slope, which we do have. So let's try working it out this way and make sure we get the same answer. Y minus y1 equals m times x minus x1. So our x1 and y1 are the point that we're using. So instead of calling them x and y, we're going to call them x1 and y1. And then we know what m is. So I would have y minus 5 from our point is equal to m, which is negative 2/5, times x minus the x from our point is 3. That gives y minus 5 is equal to, I'm going to distribute through the parentheses, negative 2/5 x. I knew I was missing something. Negative 2/5 x plus 6/5. And then if I add the y over, or sorry, add the 5 over, we get y is equal to negative 2/5 x plus 31/5. Again, since this is a function, let's write it in function notation. and we get f of x is equal to negative 2/5 x plus 31/5. We get the same answer either way, so feel free to use whichever form is more comfortable to you. We're now going to make another linear function. A town's population has been growing linearly. In 2002, the population was 51,000, and in 2005, the population was 55,500. Write a function p of t to write the population p of the town t in years after 2002. We have to be really careful with this one because our input value t is the number of years after 2002. So when we go to make our points, we have to make sure that we're using the correct t value. So when we write our ordered pairs, our input value is t, and we are getting out p of t. So our first ordered pair, t is the number of years after 2002. Since we're in 2002, that's 0, and the population was 51,000. In 2005, that's 3 years later, the population was 55,500. So we need to find our slope. That's going to be 55,500 minus the 51,000 divided by 3 minus 0. That gives us 4,500 divided by 3, which is 1,500. So our slope is 1,500. We're trying to write a function p of t that represents the population, and it's a linear function. So we're thinking in the form mx plus b, but our input isn't x, it's t. So I need to make sure I'm using the right variable. We just found what m is. M is 1,500, so I can replace that. B is our y-intercept, is how we usually think of it. But in application problems, what that y-intercept is usually represented by is your initial value. Our initial value is what happens when our input value is 0. Our input value is t. So if t is 0, then we're in the year 2002. In the year 2002, we know what the population was. It was 51,000. So my b value is 51,000, and we have our function. P of t is equal to 1,500t plus 51,000.